Hello and welcome to Manifest Maths. In this video we're going to look at Unit 1, Sequences and Series, in particular the binomial expansion. This is going to be a two-video series. We're going to look at some more basic questions at the start and then some more complex questions at the end. We're going to return to this sample paper question at the end of the second video to see how much you've learned. Okay, so this is the information given in the formal booklet on binomial series. You'll notice there's two main types. First one is a plus b to the power of n, and the second type is 1 plus x to the power of n. You'll also notice some notation which is nr. This means ncr, and it's useful for finding the coefficients in the respective parts of any series expansion. Okay, I'm just going to go through how you would find these coefficients and how you would use them in, substitute them in to this formula to obtain them. So, for example, let's say we had the expansion of a plus b cubed. Now, we could use the binomial expansion formula for this, or we could expand it out in the good old-fashioned way by doing a plus b times by a plus b times by a plus b. Now, I'm going to do this to emphasize where these coefficients come from and how you can use the formula to obtain them. Okay, a times by a is a squared. We've got a times by b and then b times by a, which gives us 2ab, and then b times by b, which is b squared. We're going to times it by a plus b again. We'll times everything by a first, which gives us a cubed plus 2a squared b plus ab squared. Then we're going to multiply them by the b, which gives us a squared b plus 2ab squared, and then b times by b, which is b cubed. We're then going to collect together the like terms. The first term and the fourth term are both a squared b, which gives us 3a squared b, and the third term and the fifth term are both in terms of ab squared, which gives us plus 3ab squared. The last term is unsum. You'll notice there's 4 terms. So if we raise something to the power of 3, that means we have 4 terms altogether. Now the coefficients for the second and third term are 3. Okay, that means that there were 3 combinations of a squared b when we did this expansion. The bigger the n term, the more combinations there could be of those. So for example, if I raised a plus b to the power of 4, then I would have more combinations of a squared b, and then my coefficients would be more than 3. Okay. Now, how could you obtain those numbers using this formula? Okay. Well, our n value was equal to 3, because we were raising to the power of 3. And we want to find out what the coefficient is for the second term. So r is equal to 2. We would substitute that into this formula. So we'll have 3 factorial over 2 factorial times by n minus r factorial. Well, 3 minus 2 factorial gives us 1 factorial. So this ends up being 3 times 2 times 1, which is 6, over 2 times by 1, which is 2, times by 1, which gives us 6 over 2, which gives us 3. Okay. Now, if the power is low, like cubed or even to the power of 4, you could do the full expansion like so. As the powers get bigger, obtaining these coefficients could get a bit more complex. Okay. So, for example, let's say that I had an n value of 8. No, let's not go that high. Let's say an n value of 5. So we were raising something to the power of 5, and I want to find out the coefficient of, say, the third term. I would do 5 combination 3, which would give me 5 factorial over 3 factorial times by 5 minus 3 factorial, which is 2 factorial. 5 times 4 times 3 times 2 times 1 gives us 120. 3 times by 2 times by 1 is 6, and 2 factorial is 2, which should give us 120 over 12, which gives us a coefficient of 10. So there'll be 10 ways of making that third term if I was to raise these brackets to the power of 5. Okay. Now, there is a quicker way of finding these coefficients. Okay, and you can use Pascal's triangle. Okay. This could be a way of saving time. To find the coefficients, you start off with 1 at the top, and you write 1 and 1 underneath, and then you continue this down by adding the 2 terms above. So this will be 1, 2, 1. Next one will be 1, 3, 3, 1. Then 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6 and 1, and so on. Now it's important for you to understand that the first line here is if we raised a plus b to the power of 1. That means we'd have 1 of each. Okay. The second one would be if you raised a plus b squared. Okay. And the coefficients are 1, 2 and 1. Now you can see that up here. Look, when I did this first expansion, we had 1a squared and 2ab and 1b squared. When we raised to the power of 3, so when n equals 3, the coefficients are 1, 3, 3 and 1. As you can see, I did that here. Okay, and so on. So if I raise to the power of 4, my coefficients would be 1, 4, 6, 4, 1, and then to the power of 5, and so on. And we could continue this down. Okay. What you'll notice is if the expansion is just 1 plus x to the power of n, okay, the first term is always equal to 1. The second term is nx. Okay. Now what you'll notice is when you raise something to the power of 3, the first coefficient is 3. When you raise something to the power of 4, the first coefficient is 4. Okay. So that's what that first term is. The second term, okay, would be x squared. The third term, sorry, would be x squared, and then this would be the factorial element here. Okay. N times by n minus 1 over 1 times by 2. So on. So I'm going to use both methods in this video, okay, and I would encourage you to think about which one would be most useful in each circumstance. The general rule is, if you have 1 plus x to the power of n, then it might be easier to use this, but if you have a plus b, where a and b are 2 numbers, it might be easier to use this method, okay? Right, let's have a look at the question then. So, we have the expansion of 5 plus 2x to the power of 3, okay? And what I would always encourage you to do is we need a plus here, okay? And this last term, they are together, so I always encourage my students to put a bracket around that 2x, okay? Now, we are going to use this expansion method first, okay, with my a being 5 and my b being 2x. So, when we expand this, the first term, we can have a to the power of n. Now, n is equal to 3, so we have 5 to the power of 3 for the first term. For our second term, okay, we need to find what the coefficients are going to be. So, quick use of Pascal's triangle. We have 1, 1, and 1. The next line would be 1, 2, 1. Then 1, 3, 3, 1. We know this because this is in the example I did earlier on. So the second coefficient is going to be 3. So it'll be plus 3. Then we have 5 to the power of, so 5 to the power of 2. So the power is going to reduce by 1. Look, we have a to the power of n minus 1 times by b, which would be 2x. We could put that to the power of 1 if we wanted to. Our third term will be plus 3. Our power for 5 is going to reduce by 1 again, so it's going to be 5 to the power of 1, and then 2x squared. And our last term, the coefficient's 1, so we don't need to write the coefficient, and it's just going to be 2x to the power of 3. Now this does need to be simplified. I just want to go through some basics again here. The first and the last term you notice are both to the power of 3. For the 5, the powers are reducing each time, so it goes 3, 2, and 1. And for the 2x, the powers are increasing every time. So 2x to the power of 1, 2x squared, and then 2x to the power of 3. So we have 125 plus 5 squared, which is 25, times by 3, which is 75, then times by this 2 here, which is 150, x. The next term, we've got 3 times by 5, which is 15, 2 squared, which is 4, and 15 times by 4, which gives us 60. So it'll be 60x squared. And the last term, 2 to the power of 3, is 8, and x cubed after. So that is our expansion. Okay. Now what that means is if we substituted x equals a number, so for example, let's make x equal to 2, we would get the same answer if we substituted into this term as if we substituted into this original term here. Okay. Right, if you pause the video and give this one a try, just give you a hint with this one before you start it. It might be desirable to obtain a plus symbol in the middle. So we're going to have 1 plus and then minus 2x, which we're going to raise to the power of 6. Okay. You can use this formulation here, or you can use your Pascal's triangle to help you. Okay, so pause the video and give this one a try. So hopefully you've had a chance to try that question. Okay, I'm going to use Pascal's triangle using the term for the power of 6. So squared to the power of 3, to the power of 4, to the power of 5, to the power of 6. That gives me the following set of coefficients to use. So my first term is going to be 1 to the power of 6, which is just going to be equal to 1. My second term is going to be my coefficient, which is 6, times by minus 2x, which is my x term. My third term is going to be 15. Now, this question only wants the first 4 terms, okay? Otherwise, we could be going on for a while. So the third term, the coefficient is going to be 15. Okay, and that's going to be times by minus 2x, this time squared. And the fourth term is going to be plus 20 minus 2x to the power of 3. Now, just to show that this would go on, I'm just going to write plus and then 3 dots after. And be careful with the minus symbol here. You have 1 plus 6 times by minus 2x, which gives us minus 12x. This third term is going to be positive because we're going to have minus 2 squared, which gives us positive 4, which is times by 15, which is 60, and then the x squared. The third term, we're going to have minus 2 cubed, which is minus 8. We times that by 20, which gives us minus 160 x cubed. Now what you'll notice is, in this particular expansion, every other term is positive. First one's positive, second one's negative, and so on. This will happen if you have a minus there. Okay. To eradicate that, I would encourage you to always make it into a plus and bracket together the x term with the minus symbol. Okay. Right. Now, there's lots of questions for you to try here. This comes up very often. So this is the first question, and the second question, and the third question. Then there are also 4 more questions on the next page, and then for luck, 2 more on the back. Okay, this is definitely worth practicing. Okay, it's 100% going to come up in your exam. So if you go back and pause the video on this page, then this page, then this page, and give these questions a go, the answers and solutions will be on the next few slides. Okay, good luck, and make sure you check your answers. So here's your solution for the first question. The key with this question is just, again, to have changed the question to a plus and a minus root 2. And then obviously be careful, when you have minus root 2 to odd powers, that's going to change that term to a minus, all right? So minus 2 to the power of 1, minus 2 root 2 to the power of 1, for example, will make this entire term a negative quantity, okay? So every other term here is going to be minus quantity, all right? And when you combine them together, you end up with an answer of 89 root 3 minus 109 root 2. The second part of the question, it tells you that this value is approximately equal to 0. Okay, it's not exactly equal to 0, but it's approximately equal to 0. Then asks you to find an approximation for root 6. Okay, so if you put 89 root 3 minus 109 root 2 equal to 0, and then bring the 109 root 2 over, okay, that allows you to take the numbers to one side, which is 89 over 109, and bring the root 3 under the root 2. Then if you rationalize the denominator by timesing top and bottom by root 3 root 2, you end up with root 6 over 3. And the last step then would be to bring that 3 up and times it by the 89, which gives you 267 over 109. Now you could run that on your calculator to find the decimal, and also then run root 6, and you'll find that they are remarkably close. Okay, so compare this to your answer and see how close you were. Hopefully you got it correct. The next question, okay, so our n value is equal to 8, and again you had to write this minus x over 2 in some separate brackets. It only wants the first 4 terms. Okay, now for this one, what you'll notice, what I did here is actually use the notation n minus 1 over 1 plus 2. Okay, now with regards to simplifying this, okay, again, the first and the second and fourth term were negative values. Okay, so you have to just be careful with regards to that question. Okay, why are these coefficients changed? Okay, well, that's because if you had used Pascal's triangle, you'd have had your coefficient for the third term as 28, which is 56 divided by 2. But remember, you also have x over 2 in the bracket, which when you squared would give you x squared over 4. Okay, so that changes the coefficient. You could have done 56 divided by 4, then divided by 2, which gives you this value of 7. Okay. Part B. Okay. It says the first two terms of the expansion of x are 32 and minus 240 respectively. Find the value of n and the value of a. So in order to answer this question, you have to use the fact that the first term was 32. So 2 to the power of n was 32, so n was equal to 5. Then expand 2 plus a x to the power of 5. To find the second term, you only needed the second term. So the coefficient would have been 5 times by 2 to the power of 4 ax, which gives you 80a. And it tells you that that's equal to what? Minus 240. If you divide the minus 240 by 80, you end up with minus 3 for your a value. Okay, next question. Hopefully you obtained 1 plus 14x plus 84x squared. You only wanted the first 3 terms. Okay. Again, you could use Pascal's triangle or this notation here. For the next question, it wants you to find the first 2 terms of the expansion of 1 minus 4x times by 1 plus 2x to the power 7. So you're going to use your answer from the previous question and times it by 1 minus 4x. If you expand that out by timesing 1 by all these terms and minus 4x times by all these terms, you end up with the following expression. Okay. Then you can group together your x squares. So you have 84x squared minus 56x squared. The 336x to the power 3 is irrelevant because it's not in the first 3 terms. So your final answer was 1 plus 10x plus 28x squared. Your next question, using the binomial expansions. This is one whereby using a plus b to the power of n is probably the most desirable. Again, use Pascal's triangle to find your coefficients for 5. 5 as a power comes up a lot. But remember, I would attach the minus to this root 3 here. Okay? So again, that means that every other term is going to be negative. So this minus root 3 makes the second term minus 8d. The fourth term, minus root 3 to the power of 3, is going to be 3 root 3, which when you multiply it by 10 times by 2 squared, which is 40, gives us the minus 120 root 3. Okay? Lots of these can be combined together. In fact, you have to obtain the answer in the form a plus b root 3, where your a is 362 and your b is minus 209. Okay, the next question. Again, I would have made a plus and attached the minus to the 1 in here. Okay. Again, the effect of that is going to be making every other term a negative. The first term, root 3 to the power of 5 gives you 9 root 3. The second term becomes negative because of the minus 1. The third term will be positive because minus 1 squared is positive 1. Okay, and hopefully you end up with 44 root 3 minus 76. Next question. This time n is equal to 4. Okay, there's already a plus in here. Still getting the habit of bracketing off the 2 over x. So you have x to the power of 4. Your coefficient using Pascal's triangle, first coefficient is 4. So it'll be 4x cubed times by 2 over x to the power of 1. You could have put that to the power of 1 there if you wanted to. The next coefficient was 6. The power of x reduces down to x squared. And then 2 over x all squared. And so on. Be careful when simplifying here. Alright, making sure that you also raise the x at the bottom to those powers. And then when you combine the terms together, you should end up with the following answer. Then part B, the coefficient of x squared in the expansion of 1 plus x to the power of n is 55. Given that n is positive integer, find the value of n. So, your first step would have been to expand. Now you could have used that directly. Use the formula here for that. Okay? And we're interested in the third term. We're told that this coefficient must be equal to 55. Okay? Now, at the bottom is 1 times by 2, which is 2. So if you double the 55, you end up with 110. Expand the brackets on the left and bring everything over to one side. You end up with a quadratic, which needs to be factorised. There's two possible answers, minus 10 and 11, but it tells you it has to be the positive answer. So n would have been to the power of 11. Okay. Next question, in a binomial expansion of a plus 3x to the power of 5, the coefficient of the term in x squared is 8 times the coefficient of the term in x. So what you had to do in this case was start to expand to obtain your two expressions for x and x squared. Okay. Now the coefficient for x was 15a to the power of 4, and the coefficient for x squared is 19a to the power of 3, and it tells you that this one is this one's 8 times bigger than this one. So 8 times by 15a to the power of 4 equals 90a to the power of 3. Then you have to just solve this equation, bring the 120 into the 90, a to the power of 3 into the 4, which gives you a is equal to 3/4. Okay, then the first question is very similar to the first one I did on the first slide, and this is your most basic kind of expansion. Then it wants you to use that answer. So you're going to let a be equal to 1/4, and you're going to let b be equal to 2x, and then you can substitute those directly into your initial expansion. It wants the coefficient of x cubed, okay, which is going to be this fourth term. Okay, so you're going to substitute a as 1/4 into that, and b as 2x into that, and then simplify, which gives you a nice answer of 5. Okay, next question. Again, one of your most basic expansions, right? It's the power of 4, so there'll be 5 terms. a to the power of 4. Your coefficient is 4, then 6, then 4, then 1. So we see 4, then 6, then 4, then 1. And the power of A reduces and the power of B increases, with B being root B. Okay, that should give you this term. Then it wants you to deduce an expansion with this. Now it's only worth 2 marks. Okay, so the first thing to understand is that if you had A minus root B to the power of 4, that will make every other term a negative. So on the original expansion, we had plus 4a cubed times by root b. So now we're going to have minus 4a cubed root b. And the fourth term is also going to be negative. So when you add these two together, every other term is going to cancel. Okay. So essentially what we have is 2a to the power of 4 plus 12a squared b plus 2b squared. We're combining this and this, this and this, and this and this term. Okay. Right. So this is going to end this particular video. Next, we're going to look at a different type of question. All right. And then we're going to answer the question that was in the initial slide. Okay.